Good evening, engineers. Let's give a few more minutes. Medyo maaga pa naman sa 7:30. All right. Good evening, engineers. Good evening sa inyong lahat. Welcome to another edition of the ACMV series given to you by Even Learning. I hope you had a good weekend and everybody's safe and doing okay. We're glad to see you here participating in this training. This training for tonight, we are doing the overview for duct design. This training will help you to learn how to differentiate types of ducting, differentiate types of duct accessories and its uses. And then yung pinaka may importante natin is to know how to size the ducting system. And then we're also giving out some useful apps and programs. This training is approximately 1 hour, including the question and answer. As we go along with this training, if you have question, please feel free to write on the comment section or unmute yourself and ask your question. Okay? As we go along, kapag ka merong nagbigay ng question, during the presentation, we'll try to get them. And if some questions remain unanswered, we will get back to you after the training, or you could send me an email at evenlearning.desg@gmail.com. Okay, so I'll share my screen for you guys. Give me a minute. There you go. All right. So for tonight, our training is under ACMV series. We're already at part 3, overview of duct design. So we're already done with part 1, the overview of heat load calculation, part 2, the mechanical ventilation calculation, and we're now at part 3, overview of duct design. Again, I'm Donnie Matthew Calpo Gabriel. I'm a professional mechanical engineer. I'm from Even Learning. So if you have some questions, if you want to talk about something, you can email me at evenlearning.sg@gmail.com, or you can WhatsApp me, Viber me, call me, SMS me at my number 938-95128. All right. For tonight, we will learn a few different things. First, we're going to learn the different types of duct, differentiate the duct accessories and its uses, how to size a duct, and some useful apps and programs. So I will tell you what apps and what programs that I use when designing my duct system. All right, so we'll do it first. First is the different types of duct. All right, there are different types of ducting. The first type, the one that we are commonly see, is the point of options. There you go. The one we usually see are the metal type or the metal sheet, GI ductings. This is the most common and most widely known used ducting system. However, there are also different types of ducting aside from the GI sheet or metal system. We also have the plastic. Sometimes we use this at your small air conditioning units because they are flexible. They are usually on the flexible type. So the PVC types are flexible types. And also some fumes or some air that cannot be used with GI. So example are those in kitchen that are corrosive. So we use different types of, for example, plastic to use on the ducting system. And also those that are fashionable and away from the norm, they use fabric. So this is the new type of ducting system now, the fabric type ducting system. So these are the different types of a ducting system, the metal, the plastic, and the fabric. However, to size them, it's very similar. It's the same principles and same calculation. So if you size one, if you get the size of one duct, you will get the size of different types of ducting. So it's the calculation to size them is almost the same. So there's not much significant difference on them. So for now, we will assume first, or we will focus first on the metal type ducting. So we will see how to size up those metal ducts. Okay. Duct accessories. So what are the duct accessories? Duct accessories are different types. So first is the terminal units on the duct. terminal units meaning these are the things that you put at the end of the ducting system. So usually these are the grills and your diffusers. So grills and diffusers have same use or same function, is to diffuse or to spread out or distribute the air inside your ducting system. So these are the ones when it's going out now from your ducting system. This is the one that you use, grills and diffusers. The different shapes and sizes are for aesthetic purposes. So if your architect wants a circular duct, a circular diffuser, so that it would match the theme or the layout of his architectural design, then we use as such. Or those that are concealed, like the track, this one. The architects love to use this one because it's concealed. It doesn't affect any of the space's aesthetic design. We use that. For the big open spaces, we use this small one, the jet diffusers, so that it could have a long throw, so the space can be air conditioned or conditioned space, even though there's a big spaces in between. All right. Another type of duct accessories are the dampers. So there's three kinds of dampers. This damper is the non-return damper. This damper is the volume control damper, and this damper is the fire damper. So these dampers have the same function, is to restrict the air inside the duct. So they have different purposes of restricting them. So for example, this non-return damper, its purpose is to allow flow from one direction, but 100% restrict on the opposite direction. So air can go from here to here, but not from here to here. Okay? Excuse me. This one is the volume control damper. It restricts the flow of air according to your desire. So if you want the air to be restricted at 50%, 100%, 45%, 70%, you can do so using the volume control damper. And fire damper is used to restrict the air movement according to temperature. So if the temperature of the air is too hot, the signaling there might be or there's a potential to have fire, this fire damper will shut. You see this one is like a curtain. So this metal curtain here will drop down when it's too hot, restricting the flow of air, preventing the spread or the spreading of the fire. Another one is a silencer or sound attenuators. This you put inside the ducting system so that the noise from your air handling unit or from your equipment does not transfer to your ducting system and does not transfer to your space, air-conditioned space. So parang the low humming, rumbling noise of the air handling unit will not be heard from your equipment room to your air-conditioned space. So example, this is an example, an office area, typical office space. So all these duct accessories, where will we see and where will we use these duct accessories? So example, this office space, I'll just blow it up for you guys so you can see better. So this office space, assuming we have this area, this conference room. Assuming this conference room is 7.25 square meter. From our part 1 of this ACMV series, we have the rules of thumb, so we could assume or we could safely calculate that this conference room would require an airflow of 1,032 liters per second of air. The orange line is the ceiling grid. This is the proposed ceiling grid or assumed ceiling grid. If you would notice, this ceiling grid is rectangular in shape. We used 1,200 by 600. So this 1.2 by 6 is a standard ceiling grid for office spaces. There's also 600 by 600. But in this time, we use 1,200 by 600. So standard of ceiling grid for office spaces. So you can see here at the bottom, at the corner, SS553 or Code of Practice for Air Conditioning and Mechanical Ventilation for Buildings. The local code specifies the dBA or recommended ambient sound level. This is the excuse me. This is the sound level for each spaces required by that requires air conditioning space. So for example, on cinema based on the use of the area, excuse me, based on the use of the area, the cinemas needs to be quiet. So your air conditioning or your air conditioning system should not be making any sound above 25 decibel. It has to be quiet. So your distribution of air has to be quiet also. In our space, our conference room, it says there, it requires at least 35 dBA. So the maximum noise inside the conference room, ambient noise, which means when nobody's there, when you're just quiet inside there, you would not hear a noise higher than 35 decibel. Okay? Okay. For my air conditioning system, I need 1,032 liters per second. I put how many? Eight terminal units or 8 diffusers. These 8 diffusers would have 129 liters per second per diffuser. So very simple, no? 1,032 divided by 8, 129 each. So how did I get 8 diffusers? How did I know that I need 8 diffusers? So first, each diffuser needs to be spaced 3 meters apart. How did I know that I need to space each diffuser 3 meters apart? Because each diffuser has a throw, meaning when air comes out from one diffuser, the air can travel up to 4.5 meters from the center. So this small square here is my diffuser. It can throw air up to this area, 4.5 meters from here. So from here all the way to here is 4.5 meters roundabout. What's the significance of 4.5 meters? So you see, if my next diffuser here at the corner is more than 3 meters, here in the middle, I may have a hot spot or a space in between that air doesn't reach to. How would I know? See, I put the 4.5 here and the 4.5 here on this one. There's no space here at the corner. If I make it smaller, I would have a small space here, and which means this area, air conditioning throw cannot be reached. Same as here. So you see here this small diffuser here. The throw is 4.5, meaning on this small area, on this small corner, air conditioning or aircon will not be reached. This will be considered your hot spot. So you want to avoid as much as possible these hot spots. So engineer, why don't I just adjust all of these 8 diffusers so that there's no hot spot? On the other, if I reduce this hot spot here, I will go here. I will have hot spot here on this side. So it's your the most efficient. No? This is the most efficient way for you to distribute your air. It won't, air distribution won't be 100% perfect or 100% no hot spot, but at least you get the most out of it, the most efficient design that you can get. All right. Why don't I just adjust this one a little bit? Well, you see on your ceiling grid, you should also need to consider the aesthetic of your space. The ceiling grid is 1,200 by 1,200. If I adjust a little bit, which means the ceiling grid needs to be customized just for my taste or just for my dimensions or layout. No. Sometimes we have to give and take. Sometimes the architect will say it has to be here. So you just need to get the most efficient way of laying out your terminal units. All right. Here, we're back to here. So earlier we said the conference room has a 35 decibel limit, or which means the sound level cannot reach more than 35. So to select a diffuser or terminal unit that's less than this one, remember our flow rate is 129 liters per second for each diffuser. Here, this is the performance data of diffuser. Notice that the face area is 600 by 600. So face area for diffusers, the standard face area for diffusers is 600 by 600. Check with your manufacturer if they can produce you diffusers out of standard size. So usually they can give you diffusers, but don't ask them to make 575 or 580. It has to be in an increment of 50s and zeros. So 550, 500, 450, 400, but don't ask them to make 425 or 450. No, they won't do it. So but the standard size that are regularly available in the market is 600 by 600. That's why our ceiling grid is 1200 by 600. Integer of six differences by 600. So here, the conference room is at 35 decibel. You would see my flow rate is 129, so I'm between 120 and 140. So at 140, my decibel is 35, but I'm less than 130, so I would know that my sound level would be less than 35. My flow rate is 129, so I would also know that my throw is more than 4.5. I would assume 4.5 worst case scenario, but based on my flow rate, it would be at least more than 4.5, less than 5. Excuse me. More than 4.5 meters, but less than 5 meters. Here also, it will show you on the corner here the face size. So here it's face size or the duct size. So this is the face size from here to here. This is the dimension or the terminal unit that can be seen. And this one is the duct connection. This one is the size of the ducting that needs to go inside, that needs to be used. So you can see here, sometimes you can buy the terminal unit with the VCD or volume control damper, or sometimes you can specify, I don't want the volume control damper. So two options, no? You can have one with a volume control damper and the other one without the volume control damper. Any questions? No? No questions? Okay, I'll continue. So my terminal units now is 8 numbers of 600 by 600 ceiling diffusers.
Hello sir, may question po.
Yes, sir.
So sir, yung kinonsider mo dito sa presentation mo, rectangular yung diffuser natin.
Yes, sir.
Hindi, okay,
square.
Okay, sir.
Square.
Yun lang, sir.
Okay. So how would you know if it's rectangular or square? Here on the corner there, it says they are 600 by 600 face size. Right. So like what I said, you can use a different size diffusers. You just need to check on your manufacturer's catalog. The flow rate, the noise level, and the throw level. So I would do the same process to the whole office area. So I would get this one, ensuring or minimizing the hotspots. You can see I still have hotspots on the edges and in the corners, no? Especially here in the lobby corner, I have the biggest hotspots. For those who would like to record this presentation, you don't need to. This presentation is available at Facebook. So you can go to our page, Even Learning page at Facebook, and you can see this these recordings posted there. All right. So again, I just, what happened in the conference room, I repeated the process and was able to get this layout. So the first thing for your ducting layout is for your terminal units. You need to know the location of your terminal units. After you know the location of your terminal units, then you can design or you can put or you can lay out your duct. Assuming your air handling unit is here in the corner. Assuming it's here in the corner. This is the proposed duct layout. So how would you know how to lay out the duct? Well, actually, there's no rule or there's no what do you call this? There's no book that will tell you it has to go straight, it has to turn right, it has to turn left. No. There's only a guiding principle. The guiding principle is, there you go. We want to keep the pressure inside the duct as low as possible. Meaning, you have to keep it as short as possible. But of course, you don't want the ducting to go here and then go here and then make one big round. No, you don't want that. You want it the shortest way possible from point A to point B. Meaning, if you have the shortest distance, it will also give you the smallest fan size needed. So this is what we're trying to do. No, there's no rule or there's no guideline that will say you have to go this way, you have to go that way, you have to have this many diffusers in one area, this much at this area. No, but what we're trying to do is to make the pressure drop. This is the force of air from your air handling unit all the way to the last terminal unit or the farthest terminal unit as low or as short or as minimal as possible. Okay. So we will discuss this pressure drop later, no, as we size the ducting, as we determine the size of each ducting. All right. So going back to our duct accessories, where can we find these duct accessories? So these duct accessories, the volume dampers, can be found here. Usually they are put there to restrict or to make sure that there's enough flow or to restrict the flow going through one area. So example, on this layout, the air handling unit is here. When the fan blows, the highest pressure will be on this area. So we put a volume damper here on this sub-main lines to restrict the air to ensure that there are enough air going on the last area. That's why we put volume control dampers on strategic places. All right. We also put fire dampers. Now, fire dampers is based on your architect doing their fire compartments, but it's usually to prevent fire from one compartment or from one area to transfer to another. If there's fire here, this ducting is like a gateway, like a bridge from one area to another. So you have to control that. So when there's fire, this fire damper will restrict the flow of air from one side to another. Duct silencers are usually installed after the air handling unit so that the noise from your air handling unit will be muffled, will be attenuated by this duct silencer, and it will not go inside your office. Another example, this one an example of a toilet. So toilet, assuming 506 cubic meter per hour, ventilation of air is 10 air change per hour. This 10 air change per hour was discussed in our second ACMV series, overview of ventilation calculation. So based on our calculation, we've put strategic places where the exhaust grills or your terminal units will be placed. Again, this is our proposed ducting layout. And these are the duct accessories needed. So same, you can see there's volume control damper on strategic places. So there should be one more here. But here we put NRD or non-return dampers. So non-return dampers prevents airflow from one side but allows airflow from the other. So for example, this is your fan. It allows the fan to blow air from here going this way. But sometimes this toilet is turned off, or this toilet nobody's using, especially at nighttime. So this toilet, there's no more employee, and some employee went to this toilet and turned on the fan. So this fan will blow air, and this damper will prevent the flow of air from this side going to this side, going to the other side. So from the fumes here, or the odor from here will not travel from here going to the other side. So that's the purpose of your non-return dampers. All right. So we discussed the uses of your duct accessories. Now we will go to how to size your ducting. First, I need to tell you the ideal duct shape. The ideal duct shape is circular duct. When we size a duct, we always refer to the size in circular. All our calculation programs, graphs are based on a circular duct. But we all know it's not possible to always have a circular duct. So we have alternatives. We have an oval duct and we have rectangular ducts. Rectangular, square ducts, they're the same. So we just call them all rectangular ducts. All right. We use different instruments to size a duct. So this one is the slide rule. So these are the slide rules that I personally use. So this one is the more expensive one that we buy. This one is the one that you get free from your aircon supplier. When you size a duct, you need at least 3 parameters. The blue parameter from this train calculator is your flow rate and your frictional loss. All right. When you have the flow rate and your frictional loss per meter, it will give you the circular size of ducting. So that's the parameter that you need, no? Flow rate and frictional loss. Another one is your flow rate and your velocity. Based on the velocity inside the duct on your given flow rate, it will also give you the circular size of the ducting. This green portion here on the train is the conversion of this circular duct to rectangular duct. This would be one side and this is the other side. So example, you get 200, you follow the line, it says there 200. So your duct size is 200 by 200 at this circular duct size. All right. So when you're sizing a duct, it's either you're sizing based on flow rate and frictional loss, or flow rate and velocity. Okay. So here is this is the slide rule. This is the graphical representation of it. This graphical representation can be found in Figure 10 at ASHRAE Fundamentals 2017, page 21.9. So it's the same, no? Frictional loss on your horizontal line versus your flow rate, the vertical line. Okay. Or your velocity, the diagonal line here. This one is your diagonal line versus your flow rate. And it will tell you the duct size here on this line, this diagonal line. Example, frictional loss at 100, air quantity at 100. So frictional loss at 1, air quantity at 100, you see the intersection point, and you can see here, it's 170 or 200 mm. So that's how those are the parameters that you need for your duct size. Or more simply, you can use a program or a calculator that will give you the duct size. So still same, no? The flow rate, the frictional loss or head loss, or the velocity. So if you at least give them 2, it will give you the diameter in circular duct. This one will just convert your circular size into rectangular size. So all these three, your programs, your graph, and your slide rule gives you the same thing, requires you all the same parameters. Okay. So example, like what I said earlier, you either have your head loss or your frictional loss or your velocity, meaning your duct sizing must be based on either constant velocity method or constant pressure drop method. As a designer, no, you can choose whatever velocity you want. You can choose whatever pressure drop you want. But when you do that, the next engineer or the next person looking at your design will be scratching his head. How did the heck did he design this? So to make our lives easier, we use constant. Okay, there will be time that you would need to switch between velocity method and pressure drop method, but I strongly recommend you not to. So if you use velocity method, please use velocity method throughout your whole ducting system unless otherwise impossible to do so. Or if you use pressure drop, please use pressure drop method throughout your ducting system. So what does constant velocity method mean? Which means your ducting system is based on a constant velocity. Okay, so we'll go one by one with the velocity method. Going back to our assumption, this conference room. Earlier, we assumed that this one is 209 liters per second per diffuser, or a total of 132 liters per second. Okay, using our velocity method. Using our velocity method. For branched ducts meaning those ducts that are connected to your terminal unit. The design for this branch duct is usually at 4 meters per second. So using our program, so here on our presentation, I use the program so you can see. If I use a slide rule, you can see how I got the size. So for presentation purposes, I use the program. So at 129 liters per second for each branch, I use a constant velocity of 4 meters per second. I got the circular size at 202 mm. So the rectangular duct that are given to us is 200 by 175. If you are selecting ducts, please do not select ducts based on the integers of 50 and hundreds only. Do not size ducts at weird dimensions like this 175. Nobody will do 175 for you. Excuse me. Either you do 150 or 200. We don't want to go lower than the requirement, so we go higher. Because if we go lower than 175, which means our velocity will also increase. We want our velocity to be at 4 meters per second. So our duct size is 200 by next size up 200. There you go. So we select 200 by 200 on our terminal unit based on the constant velocity method. Branch ducts, constant velocity of 4 meters per second. All right. Next is your submain. Submain is your ducting after your main duct. So assuming that the duct in the middle, the biggest one is your main duct, the ones here in between your main duct and your branch duct are called submain. Right? Submains are sized at 6 meters per second, constant velocity. So assuming again that 129 liters per second per diffuser, we're only going to assume 1, 2, 3, 4, 5, 6 because this duct is using only 6 diffusers. Okay, so there, 6 diffusers only. So 129 times 6, 744 liters per second. At 744 liters per second, 6 meters per second of duct size, I get diameter of 397. So 400 by 325. There's no such thing as 325. So we go to the next highest, 350. So our duct size is 400 by 350. As much as possible, we use a square type duct because the square duct is the nearest to your circular duct. We will discuss that later, no? But for now, as much as possible, we use the nearest square size duct. Okay. So last, main duct. So this main duct, so assuming all these flow rates, no? So the total flow rate for the whole office will be going to this main duct. So the main ducts are sized at 8 to 10 meters per second, constant velocity. So the total flow rate for this main duct is about 6,980 liters per second at 10 meters per second. I went to the highest, 10 meters per second. It requires me to go with 900 by 850 duct size with the equivalent duct dimension, circular duct of 942 millimeters. So there you go, no? So when you're designing your duct using the constant velocity method for the main duct, I would use 10 meters per second, but the requirement is between 8 to 10 meters per second. So that's the velocity method. So now we're going to the pressure drop method. Pressure drop, we'll use this graphical sizing from ASHRAE. ASHRAE says this shaded portion, the blue shaded portion, these are the areas to which you can use your pressure drop. So meaning you can only use pressure drop from 5 to 0.6 to 5. It is not recommended. You can use for whatever purposes that you may have for special purposes, but they would recommend only between 0.6 to 0.5. And as you grow, as you increase your flow rate, their recommendation also decreases in pressure drop. Okay? But for me, and my experience in the industry, the pressure drop are usually between 0.8 to 1 Pascal per meter. What is the pros and cons of using higher and lower pressure drops? If you use higher pressure drops, you would usually have larger fans. Smaller fans because larger fans because of high pressure drop. And because of high pressure drop, you will also have high velocity because your duct size are going to be smaller. And you will be susceptible to noise and vibration in your ducting. If you use low pressure drop, you need smaller fans because you would need less force to push the air. There's going to be less noise and less likely to have noise and vibration, but you're going to have a larger duct size. Larger duct size also means more materials, which means higher installation cost. So lower installation cost, but susceptible to noise and vibration, or higher installation cost, but less noise and less vibration. But for me, for my experience in the industry, I usually encounter duct designs that are between 0.8 to 1 Pascal per meter. Me personally, I use 1 Pascal per meter on all of my designs. So we're going to go back to our previous example, no? Our conference room. So this time we will use a 1 Pascal per meter of constant pressure drop. All right, constant pressure drop of 1 Pascal per meter on the branch ducts. So now, if you're using branch ducts, previously branch ducts is at 4 meter per second, submain is at 6 meter per second, and main duct at 8 to 10 meter per second. But for pressure drop method, it doesn't matter which type of duct, which doesn't matter which location of duct. Everything is sized at 1 Pascal per meter. Constant pressure drop. So at branch duct, 1 Pascal per meter, there. You can see 1 Pascal per meter. This is our previous calculation at 4 meters per second. You would see they're similar. 200 by 200 also gives me 200 by 200. So that's one good result, no? The 4 meters per second coincides with 1 Pascal per meter. Same with our submain. You see, the velocity 6 are designed previously. The pressure drop is at 1. So if I measure it at 1, it will give me the same duct size. Similar size. And also on the main duct, same. So whether you use your velocity method or your pressure drop method, it gives you slightly more likely to have the same duct size. Not always the same, especially if you have a more complicated duct system, but usually the same. The principle is you want to have a duct system that doesn't give you noise, that doesn't give you vibration, at the more cost-effective size. So at the criteria that were given to you, the 4 meters per second, the 6 meters per second, and 8 to 10 meters per second are proven by the industry, proven by previous installations, that doesn't give you vibration, doesn't give you noise, and is at reasonable cost. Of course, you can increase the velocity. Of course, you can increase the pressure drop, but you would be susceptible to noise and vibration. Going back, this is our ideal duct shape again, the circular duct. Assuming on this area, we section it here on this black line, we make a section on this black line. So this is your cross section of your office. This office, previously on our calculation, let's go back to our calculation. Our calculation, it says there at circular duct, this main duct should be at 900, at least 950 mm in diameter. All right. If I put the 900 mm in diameter, it will be this big. If I follow the 900 by 850, it will be this big. But my ceiling is only up to here. So which means I need to use a rectangular duct. So I need to convert this circular duct to this shaped rectangular duct. When you're doing a rectangular duct, you can use this one. The conversion from circle to rectangular or to square is not based on the area or cross-sectional area. ASHRAE said on ASHRAE figure 10, the circular duct, ASHRAE table 3, the circular duct is based on equal friction. So, equal friction loss at your airflow. So, for example, this is your circular duct. These are the recommended, this is the flow rate. These are the recommended duct dimension. So example, your circular duct is 300. So which means the rectangular duct is 300 by 250. Like that. When choosing, of course, there are sometimes that the size is really needs to be small and longer than the other one, like really longer. Okay. For example, here in our previous example, the main ducting, Our square duct is 900 by 850. I need it to be 500 based on the ceiling requirements. This is 300, this is 250. So this space is approximately 500. So if I change this 938 to 500 on one side, the other side needs to be 1,600. So converting this 938 to rectangular, 500 to 1,600 with the same frictional area, frictional factor. You see, frictional factor 0.1539, 0.1539. Head loss, almost the same. So we're not, again, we're not basing our size of the ducting based on cross-sectional area, but it's based on friction loss. Friction loss. With the same friction loss, I'm able to get this one at 500, this one at 1,600. However, based on SMACNA, SMACNA is the authority or the code for duct construction. Based on SMACNA, your rectangular duct should not be one length should not be greater than 4 times of the other length. So which means on a rectangular duct, 1:4 is the highest possible ratio. If you go longer than the 4 times of one side, you will your ducting will be too flimsy on one side and it will start to vibrate. Actually, more than at 4 times one side, it will already vibrate, but they still have a process to put duct stiffeners so it won't vibrate. But if you go longer than 4, you will start to have whistling sound, you will start to have vibrating sounds. So we don't recommend you choosing or designing duct sizes that are higher than a ratio of 4. One side to the other side with a higher ratio than 4. So maximum duct ratio is 4. Okay? Oh, remember that the highest duct ratio is 4. By being able to size the ducting, you will be able to now calculate for the duct pressure loss. The duct pressure loss is the force needed for the air handling unit, again, to push the air from the source all the way to the end, to the farthest area. This is called the external static pressure. So from your return to air handling unit all the way to the supply, the total force needed to push that air, the external static pressure is the highest possible pressure loss within the duct system. Usually, again, it's from the return to fresh air to the farthest point. It's not necessarily to the farthest point, but it's about 90% of the situation is usually the farthest point, but it's not the farthest point. It's the highest pressure drop. Okay, we're talking about the external, which means external to the air handling unit, not counting your fan pressure drop, your coil pressure drop, your filter pressure drop, but only on the external side of your air handling unit. That is the reason why we're designing this duct system, so that the pressure from your air handling unit all the way to the farthest point, all the way to the end, is as short and as low as possible. All right. So that's it, how to size a duct. So useful apps and programs. So the programs that I used here is the duct sizer from McQuay, the one that we used to get our duct sizes. It can be downloaded free at Daikin. So McQuay was bought by Daikin, so now it's available at Daikin. For your apps, you can use Duct Sizer. I use this Duct calculator from S&P. It's free, but you can use the official one from Ashray. It's about $9. Thank you. Any question? That's it at the end of our presentation. I remember last time somebody asked after you get the cooling load for the room, we'll be able to use that to our suppliers. I said no. So in this series has been the duct design series. We're done with parts 1, 2, and 3. The next one would be part 4. In review, this is our previous example, the office. In part 1, we are able to calculate the heat load for each area. In part 2, we were able to determine the flow rate needed for each area. And here in part 3, we were able to present to you how to size a duct to be able to get the pressure drop or external pressure loss for the duct, for the unit. With that 3 things, your total cooling, your total airflow, total cooling, total airflow, and total external static pressure. Now you can use these 3 things to give to Daikin, to give to Carrier, to give to York, to give to your air handling or your aircon supplier. They would ask you these 3 things. After you get them these 3 things, then they will be able to size up equipment. All right. Thank you very much. Is there any questions that I can answer for you guys? There's none? There's no question. We have a few minutes left for question and answer. Then if there's no question, then I thank you for joining us in another training given to you by evenlearning.sg. So if you have any question that you're able to think of after this, you can always contact me at my email evenlearning.sg@gmail.com, or you can call me, message me, WhatsApp me at 938-95128. I'll see you next in our another edition of Even Learning at overview for pipe design. So chilled water pipe design for the next meeting. And that would be on January 9 next year. So see you again next year. I hope, sorry. I saw some questions just now. Hi sir, is duct design applicable for ventilation as well? Yes. So our example earlier was toilet. So this one is for the duct design is for supply, air conditioning, and also for ventilation. So same principle, same way of getting it. How about return? So example, our previous earlier is the main ducting. So main ducting is for the supply, then submain, then terminal branch. It's the same for return side, only in the opposite direction. So we started from, on the supply side, we started from terminal to submain to main. For the return side, it's the opposite. You start from the main, then the submain to the terminal unit. But the way of getting it, the way of designing it is the same as the supply. So mirror image lang siya, supply and return. But the way for you to size it is the same way. There's a question on Facebook. Let me check on Facebook. What's the question on Facebook? Yes, this is recording. So what we are doing now is recorded on Facebook. It will be there on Facebook. You can refer back to Facebook. Yes, you can contact me. I will put my email on the chat box. evenlearning.sg@gmail.com. You can email me anything, anytime. Last module, a bill of materials para complete. Bill of materials, it would take more than an hour. So I don't think we'll be able to do that. However, I will take that in consideration. Uh, Last module, the module is ACMV controls. That will give you the bill of materials. That will give you what are the things that you need to do, because now you have your duct design. You have your we're starting to do on the installations, to have a picture on the installation side, what the things that needs to be done. So you're gonna have your duct design now. The next one will be pipe. After that too, you need your controls. So these three things, the overview of duct design, overview of pipe design, and the overview of controls, ACMV controls, will give the combination of these three will give you an overview of the bill of materials that you would need to make your ACMV installation. Duct design also depends on the size of the fan or air circulation. Well, there's two things. Armando Corpus is asking, is the duct design also depends on the size of the fan or air circulation? For our example earlier, we have calculated the air circulation first. We have determined the amount of air needs to be circulated, and based on that, we will size up the fan. Sizing of equipments or sizing of the fan, usually, in the Philippines, I don't know how is it done, but here in Singapore, you would give your airflow and your external static pressure to your fan supplier, and they will size the fan for you. All right. So we usually here is that equipment sizing is the equipment selection is based on the supplier side. So we don't actually consider the size of the fan when we design. It's the opposite. We design first, and the fan size will comply to our design. The only time that I can think of is when here in Singapore we call it ANA. In the Philippines they call it renovation. If you are renovating a space where equipment is already available and equipment is are already installed, and we're going to design based on the equipment size. So that would be a different approach, no? But on our approach, everything is new, everything's brand new, and we don't have anything yet. So if at first design, it's the equipment who will comply to our design. It's not the other way around. Yeah. Another one, vent exhaust and fresh air duct sizing same with supply. Yes, the exhaust and fresh air for ventilating purposes is the same way. So we're talking about air conditioning. The way you size up the air conditioning is the same you size up in your ventilation, fresh air and exhaust. Same way, same principle, pressure or velocity. Same parameters. If you're doing with velocity is 4, 6, 8 to 10. And if you're doing pressure drop, 1 Pascal per meter. One more question. With the pandemic, what design considerations are accounted for? Please explain exfiltration and infiltration. Exfiltration and infiltration is explained on our part 1 of the ACMV series. Part 1 of the ACMV series, heat load calculation. So there, the exfiltration and infiltration were explained. So in overview, infiltration is the intake of fresh air to one space. Exfiltration is the release of air from air-conditioned space to outside. Contact, somebody's asking me for contact number. My contact number is at the beginning of this presentation, is part of our slide. Anyway, I will put it back here in the chat group. So my contact number, if you need to contact me, have questions for me, it's 93895128. I am from Singapore, so the The country code is +65. I know that there's some who registered that are from Malaysia, some are from the Philippines. So country code is +65 here in Singapore. All right. Thank you very much. So, is it applicable? One more. Is it applicable duct sizing for small equipment like FCU and no? Sorry. So these duct sizing are for there's two types of FCU. FCU is fan coil unit. So what our discussion earlier is about air handling units. So air handling units are typically large air conditioning equipment that gives you large airflow rate. Fan coil unit or FCU are small units. Now, there are fan coil units, example, the one that you install or the split air cons that you install inside your house. They don't have any duct design, but there are some small units that needs duct design. So the ducted type fan coil unit, yes, you would need duct design. Is it different from what we have discussed? No. So whether you're using a small FCU that's ducted type, the principle are the same. The duct sizing are the same. However, you need to ensure your duct design conforms to the static pressure of your fan coil unit. Unlike AHU or air handling unit, you can specify your static air pressure or your external static pressure. For FCU, the external static pressures are set in stone. You cannot change it because it's a standard manufactured equipment. They cannot change the fan inside your fan coil unit to suit your needs. So your duct design needs to suit the static air pressure of your fan coil unit. All right? Paano mag-register sa Zoom para sa mga seminar? So for those in Facebook, if you would like to register for the Zoom meetings, you can use the registration form at the details of the event page. There's a link there for the registration. If you register, it's free. I will send you the link for the Zoom meetings. All right. So thank you. No more questions. If there's no more question, I appreciate you guys. I appreciate you attending this training, and I appreciate you guys for learning with us. And if there's no more, stay safe and thank you. I'll see you next time for the next series from Even Learning. Thank you. Bye.